Good day, everyone. This is Professor Friday coming at you one more time. Today we are going to be solving systems of linear equations, specifically three equations with three variables. So today we have 2x plus 4y minus 10z is equal to negative 2, 3x minus 9y minus 21z is equal to 0, and x plus 5y minus 12z is equal to 1. I always emphasize this with my students. I'm going to emphasize it again here today. Labeling is really important. Our goal is to use an elimination to turn the system of three equations with three variables into a system of two equations with two variables. So our first goal is going to be, I'll write this in right over here, we're going to eliminate the same variable from two pairs of equations. Now the reason that we eliminate the same variable is because that takes us down from three variables to two. And the reason that we do it from two pairs is because we want two equations. Therefore, two equations, two variables. So usually the thing I encourage my students to look for over here is a coefficient of +1 or -1. Now we only have one case of that in this problem, and that's using equation 3 with the variable x. So what I'd like to do is eliminate x, and I'd like to use equation 3 both times. So I'm going to use equations 2 and 3 to start. So recopying those down, equation 2 says 3x plus 9y minus 21z is equal to 0. Now the thing that I notice about this is they will not eliminate if I simply add these two equations together. What I'm going to do is multiply equation 3 by -3. The reason being I want to get the coefficients of x to be equal and opposite. So if I distribute a -3 through all three of these terms, I'll get the following. That'll be -3x minus 15y plus 36z is equal to -3. Add these bad boys together and x will be eliminated. That'll be -6y plus 15z is equal to -3. As I mentioned, labeling is really important, so I'm going to label this as equation number 4. Equation number 4 is the first of two equations that we're going to need to form a 2x2 system. That's two equations with two variables. Now, that's only half of the work, though, because we're going to need another one. I already mentioned that 3, the coefficient of x in equation 3 is just fantastic. I'm going to use that to eliminate x from equation 1. So I'm going to eliminate x again, and this time I'm going to be using equations 1 and 3. So I'll recopy down equation number 1. That's 2x plus 4y minus 10z is equal to -2, and then we run into the same problem as we had with equations 2 and 3. If I were to just add equation 3 to this, the x's would not eliminate. Since I got a 2x here, I want to get a -2x from equation 3. So I'm going to multiply equation 3 by -2. So it'll be -2x minus 10y plus 24z is equal to -2. Now if I add these two equations together, the x variables are going to cancel out. The y's are going to give me -6y, and then over here we'll have plus 14z, and that's equal to, looks like -4. Again, labeling is really important, so I'm going to call that bad boy equation number 5. So now, equations 4 and 5 create a system of two equations with two variables. I'm going to recopy these down over here. So equation 4 states -6y plus 15z is -3. And equation 5 states that -6 plus 14z is equal to -4. So now that we're down to two equations with two variables, we are going to eliminate again, eliminate a variable to get one equation with one variable. That's kind of the purpose of elimination, is to get rid of one of the equations and get rid of one of the variables. Reduce it down to something a little bit easier. So, we're running out of space on this page, so let's bring out the next. Now at this point, you have the option of eliminating either y or z. I notice that the coefficients of y look really nice, so I'm going to eliminate y from equations 4 and 5. The reason being they've already got equal coefficients, we just need them to be opposites now. So I'm going to take equation 4, recopy that down, that's negative 6y plus 15z is equal to negative 3. And in order to get the y variable to eliminate, we'll need a positive 6y. So I'm going to take negative 1 times equation 5, that'll be 6y minus 14z is equal to positive 4. Add these two bad boys together, and y will be gone. In addition, that'll be 15z minus 14z, that'll be 1z, and 4 minus 3 is 1. We are officially 1/3 of the way done with the problem. So, now that we have a value for z, we're going to plug z equals 1 back into either equation 4 or equation 5. We should get the same answer either way, so this is completely up to you. Looking at equations 4 and 5, I'm just going to pick the top equation. We'll go with equation 4, just because. That'll be negative 6y plus 15z is equal to negative 3. I'm going to plug in z equals 1, and the equation will become negative 6y plus 15 times 1 would be 15 is equal to 3. To finish this one off, we'll subtract 15 from both sides. That'll give me negative 6y is equal to negative 18. Divide both sides by negative 6, and then we realize we're off camera. Ha ha! And we will get a total of y equals positive 3. So now, we've got, oh boy, we've got z equals 1, we've got y equals 3. We are officially 2/3 of the way done with the problem. Next thing that we'll do is plug, what did I say, y equals 3 and z equals 1 into either equation 1, equation 2, or equation 3, and that'll give me a value for my x variable. So let's grab this sheet so that we can remember what these equations were. Equation 1, equation 2, equation 3. In equation 3, there's going to be not quite as much solving for x necessary, so I'm going to plug this into equation 3. Equation 3 was x plus 5y minus 12z is equal to 1. And then I plug in the values that I know. The values that I know are that y is equal to 3, and that z is equal to 1. And plug those bad boys in. Let's see what we get. That's going to be x plus 15 minus 12 is equal to 1, or x plus 3 is equal to 1. If we subtract 3 from both sides, we'll get our final answer, which will be x equals negative 2. So for a final answer, as far as how to express a final answer, I tell my students we want to see an ordered triple. It's like an ordered pair, except now we have 3 things in it. So we got y is equal to 3, x is equal to negative 2, and z equals 1. So in order, that would be x is negative 2, y is 3, z is 1. Always throw those in alphabetical order. So even if it's not x and y and z, it'll still be alphabetical order. Well, I hope you found this informative, and I'll see you again soon.